Hi everyone, welcome to Mr. Wagid's math class. We learned before that equations work just like a balanced scale, where the left side has to equal the right side for the equation to be true. We also learned how to solve equations using inverse operation. Today, we will be learning graphing linear equations. So what is linear? Linear came from the word line. Literally, it makes a line. So a linear equation is an equation whose graph makes a line. Every point on the line is called a solution. Now let's practice graphing this equation. Graph the equation y equal half x plus 1. For us to do that, let's make a table of values. The first column is the x, the second column is the equation, the third column is the value of y, and the last one would be the solution. Come up with 3 different values for x. You can come up with any value for x. You can write any number for x, but I want 1 positive, 0, and 1 negative. Since the equation has half in it, look at the denominator, which is 2. So it's easier for you to find numbers that is multiples of 2. And I would choose the easiest one, which is 2, 0, and negative 2. Now substitute x in the equation to find the value of y. We need to substitute the value of x, the first time is 2. In the equation, y equal half times 2 plus 1, because I replaced x with the value of x, which is 2. Now half times 2 is 1, and 1 plus 1 is 2. So y equals 2 when x equals 2. Solution are the x and y value that makes the equation balanced. And what made the equation balanced or true? X 2, y 2, so the solution is 2, 2 as an ordered pair. Now what if x equals 0? Substitute 0 for x in the equation to find the value of y. Half times 0 is 0, plus 1 is 1, so the solution is when x equals 0, y equals 1, we write it as an ordered pair 0, 1. Now what if x equal negative 2? Substitute the value of x in the equation with negative 2. You end up with y equal half negative 2 plus 1. Half of negative 2 is negative 1 plus 1 equals 0. So the value of y when x equal negative 2 is 0. So the solution for the x and y values are negative 2, 0. So the first step of graphing any equation is to make a table. So we made the table of values and we found the solutions as an ordered pair, x and y. Now we can plot those solutions on the graph. The first one is 2 and 2, so plot 2, 2. The second one is 0, 1, where x is 0, y is 1, so the second one. And the third solution is negative 2, 0. Plot on negative 2, x-axis, and the y is 0. Now connect those 3 dots, and it's enough to have 3 dots. There's a lot more, but it's enough to have 3 dots to connect them to make a line. Watch how it made a straight line, no curves in it. So the equation y equal half x plus 1, when graphed, made a line. And the red dots are the solutions on the line. Now let's graph the equation y equals 2. The first step is to make a table of values. You can have the table horizontally or vertically, it does not matter. But always the first column or row has to be the x, the second one has to be the equation, and then the y in the solution that you needed to plot. So x, again, we said you can find any value of x. So choose any number you want, but I want 1 positive, 0, and 1 negative. So this time I will choose 4, 0, negative 4. Now the equation is y equals 2. Is there any way to substitute x in the equation? No. So what do? They say in y equals 2. So always y will equal 2 no matter what x value is. So I can't change that. So the y value stays 2, and that's why I didn't have a column for y. So when x is 4, y is 2, my solution is 4, 2 as an ordered pair to plot it later. Now, what if x equals 0? Again, y equals 2. I can't change that, so y will stay 2, and the solution would be 0, 2 for me to plot it later. What if x equal negative 4? If x equal -4, y will stay 2. I can't change that because they're telling you y equals 2. So the solution will be -4, 2 as an ordered pair. Now let's plot them. Take those solutions and put them on the graph. The first one is 4, 2, second one is 0, 2, and the last one, -4, 2. Put a line through it. Did you notice something? The graph of the equation y equals 2 is a horizontal line crossing the y at 2. So look at the y-axis, find 2, and watch how the horizontal line crossed the y-axis right at the point 0, 2. So x has to be 0 for it to cross the y-axis. As a conclusion, we can say that the graph of any y equals b, where b is a constant, is a number, any number, will be a horizontal line crossing the y-axis at 0, b, where 0 is the x and b is the value of y. Now let's graph this equation. Another example, graph the equation x equal 2. I need a table of values again. I need x, y, and the solution, but this time x equal 2. So I can't come up with my own numbers because x has to stay 2 because that's what the equation is saying, x equal 2. So leave x as 2, don't come up with your own equations or numbers. Now what's y equal? Now you can come up with any number for y. The first time I can say y equals 5, so the solution is, as an ordered pair, 2, 5. I can come up with y0, so the solution would be x2, y0. And the last time I can come up with a number, it's -3, for example. So the solution would be 2, -3. Now let's plot them. Take all these solutions and put them on the graph. The first one is 2, 5. The second one, 2, 0. And the last one, 2, -3. Now connect them. Watch how you got a vertical line crossing the x at 2. So the graph of an equation x equal 2 is a vertical line crossing the x at 2. This time, y has to be 0 for it to cross the x-axis. In conclusion, the graph of x equal a, which means any number, x equal any number, is a vertical line crossing the x at the coordinate a, 0. Now let's practice graphing equations without making a table, especially if they make a vertical line or a horizontal line. There's a much easier way to do that. So the first one, x equal -5. Since x equal -5, then x always has to stay -5 no matter what the y value is. So you end up with a vertical line crossing x-axis at -5. So go on the x-axis, -5, put it a dot right there, and now draw a vertical line across it, crossing that -5, 0. To graph y equal -3, you're going to end up with a horizontal line crossing the y-axis at -3. So go this time on the y-axis, -3, and put that red blue dot and draw a horizontal line crossing the y at -3, and you're done. The coordinates will be 0, -3, where the line crossed the y-axis. Now let's practice with the word problem. The equation y equal 2x plus 3 represents the cost y in dollars of mailing a package that weighs x pounds. So the y represents the cost and the x represents the number of pounds of that mailing package. Graph the equations. To graph the equation, we need a table of values, where the first one is the x, the equation, the y value, and then the solution. The first one, come up with your own x values, and I said 1, 0, and 2. Watch, I did not use any negative numbers because you cannot have any negative amount of weight. Now substitute the value of 0 in the equation, and watch how I put it in parentheses because I need to multiply. So y equal 2 times 0 is 0, plus 3 is 3. So y equal $3 for 0 pounds. So the solution, x and y, 0, 3. Now what if x equal 1 pound? Substitute the 1 in the equation. 2 times 1 is 2, plus 3 is 5. So it costs you $5 for 1 pound, and the solution would be 1, 5. The last time would be 2. So what if the weight of the package is 2? Substitute 2 in the equation. 2 times 2 is 4, plus 3 is 7. So the cost would be $7 for a package that weighs 2 pounds. The solution would be 2, 7 as an ordered pair. Now let's graph it. Watch how I only use the first quadrant because we don't need any negative number, whether for the y or the x, the cost or the number of pounds. Watch how it made a line once you graph it. Use the graph to estimate how much it costs to mail the package. And the package weighs 1.126 pounds. So what would I do? The x is the number of pounds. The y is the cost of mailing. So look first at the x-axis with roughly 1.2 pounds. And that's the red line. Stop right on the line of the graph. And then look at the y. Stop exactly where it touches the line of that equation. And it did at 5.8, which means it costs $5.80 to mail the 1.1 or 1.2 as an estimate pounds. Now use the equation to find the exact cost of mailing. Now we're going to use the equation to find exactly how much does it cost you to mail that package. Write the equation and substitute x with 1.126 to be exact. Since x is the number of pounds, so replace it 2 times 1.126 plus 3. Multiplying them and add 3, you get 5.252. So the cost of mailing, the exact cost of mailing that package would be $5.26. So we use equations to find the exact values. We use the graph to estimate. So that's it for today's lesson. We were able to graph equations. They made line, and that's why they are called linear equations. That's it for today's lesson. You guys have a great day.